Hello friends, in this particular lecture and in the next lecture also, I will be telling you that how to write structures in C++. So the first problem which I am taking is of a complex number. Now if you look, a complex number is having two parts. The first one is the real and the second one is the imaginary. So these two parts combine when written as real plus I times imaginary, or sometimes some people also write it as imaginary times I, doesn't matter. Now whenever you have to write a structure, what is a structure? Structure is basically a user defined data type which is capable of holding several variables of different data types. So when we have to club different variables of different data types, then we can use structure, and that particular will become our uh, what user defined data type. So in this case, we will be defining a structure. The how to define a structure? It is very simple. You have to write struct, then the name of that structure, then the data variable or data members, and then if you stop it here, then this is a C style of writing structures. But if you extend this and you write functions also, that means the one which define the behavior of this structure, then it will complete your C++ style of structures. So first what I'll do is I will write a structure for this particular problem, that means of a complex number, and I will write this one using C style, and then I'll be moving to C++, and there you will be able to see that inside the structure we are keeping the functions. So let us head to the code blocks. So the first task is to define a structure. So right now I am defining a structure in C style. Okay, now look very closely. First you have to write the keyword struct and then the name. Let's say it is comp. I am saying for complex number, and then once this is done, then the data members are, let's say let's take integer only, real and imaginary. Now that's all. So a complex number will have a real part and an imaginary part. So that is how we can declare our structure. Once we have declared it, now we can create an instance of it, object of it, object of complex class. So the complex structure, let's say it is C1. Okay. Now remember, whenever we write structures in C++, by default every data member is public, means we can directly access the data members from outside this structure using dot operator. So if I say C1 dot real assign let's say 5, and C1 dot imaginary assign, let's say 2. So what has happened now? What will happen if you write like this? So a structure will be created inside the memory with a name C1, and it will be having two parts, real and imaginary. So this is all will happen with this particular statement, and with this the real will be assigned 2 and the complex will be assigned, real will be assigned 3 and the complex imaginary part will be assigned 2. So this will become 3, this will become 2. That's it. This will happen. Now so far this is the only thing which will happen. Now what I want, let's say I want to display this particular complex number in a form like 3 plus 2i. So how that can be done? That can be done using a function. So let us declare one function. So void, as this function has to display only, so I'll be using void, and let's say display, and then inside this it will be requiring it is for what? It is for displaying complex number, so it should have complex number as an argument. So comp, this is the one, and let's say c. So now I'll simply say c out, and then c dot real, because this c is a complex number and this must be having two part. Can you see here? It is having two part, one imaginary, one real. So real, and then plus, and then bracket, close it, and then c dot imaginary, then close the bracket with I. So close the bracket with I, and that's it, and bring the cursor to the next line. That's it. So how to use it? Simple. We have created one structure C1. Now this is having real and imaginary part. We have initialized it, and now I'll simply say C1, sorry, display dot, and inside it is expecting one argument which is nothing but a complex number. So I want to display C1. So if I run it now, what will happen? The complex number will be displayed. Look here, it is 3 plus 2i. So it is very simple. Now let's say I want to create another, so what was the problem? Define a structure to represent a complex number with real and imaginary part. This is what we have done here. And then it says input two complex numbers. So now one we have already done, this complex number. Another one we can also do. You can also do this with the help of asking from the user. So let's say I'm declaring another complex number C2, and let us ask from the user C out, enter real part of C2, and NL, oh no NL is required. So C in, what is the one which we have to transfer? The real part of C2. That's it. The similar thing you can do for imaginary parts as well. So enter the imaginary part of C2. So here you will be doing what? Imaginary. Once this has been done, so what will happen? With this statement inside the memory, let us delete it. Inside the memory, C2 will be created with real and imaginary parts, and inside this, if you look, now C2 real and C2 imaginary will be transferred based on the data provided by the user. So once this is done, let us also display this C2. So if you display it C2, and if I run it now, so now it is asking, so this we have declared in the initialize in the program itself, and now it is asking for the real part of C2. Let's say the real part is 4, and then the imaginary part, let's say it is 7. So our C2 is 4 plus 7i. That's it, done. Now the similar thing you could have also done for C1 also. Now the question says that pass the structure variable to a function. Okay, add the two complex number inside this particular function. So what we have to do, we have to create a function which can take two complex number and add them. So what we will be doing is we will be creating one complex number, let's say C3. So as this is a complex, so it must be having real and imaginary parts. Okay, so this is real, this is imaginary. Right now garbage will be there. So what we should be doing is we should be making a function, let's say add, and it is expecting what? It should be expecting two complex numbers. So the argument should be two complex number, and then inside it will be doing what? C1 dot real and plus C2 dot real. So real part added, C1 dot imaginary and C2 dot imaginary, they are added, but they should be taken up by whom? They should be taken up by some complex numbers, real and imaginary. So for the sake of transferring it in a smooth way, we can take a complex variable. Let's say a is that intermediate, so I can say a dot real will be this, a dot imaginary will be this, and at the end I will return this a. That's it. It is so simple. So let us do it. So now let us make one function, and let us name it as add. So what this is adding two complex numbers, so the argument should be complex number only. So complex C1 and complex C2. Okay. So now after adding, it should return also a complex number. So the return type of this particular function should be complex only. Okay. Once this has been done, then what it will do? It will add the real and imaginary parts of C1 and C2, and it will be transferring it to the real and imaginary part of some local variable. So let us take one local variable, again complex type A. Then what I'll do is A dot real will be C1 dot real plus C2 dot real. The same thing I can do for imaginary. So A dot imaginary will be C1 dot imaginary plus C2 dot imaginary. Then what we have to do is we have to return this A. So return A. That's it. It is so simple. We have done it. Now inside the program you are already having two complex numbers C1 and C2. I have directly initialized this inside the code, and this I have initialized with the help of user input. Okay, so let us create another let us give some space. So another complex, oh sorry, COMP is the name of structure. So this is the data type basically of our complex. So this is C3, let's say, and what C3 will be doing is C3 will be doing what? Will be taking up the addition of C1 and C2. So first one is C2, second one is first one is C1, second one is C2. Doesn't matter. C1 can also be second on. Instead of writing C1 comma C2, you could have written C2 comma C1. Doesn't matter. If you add 2 to 3 or if you add 3 to 2, the result will always be coming as same. Now once this has been done, then you can do what? You can simply say display the result of addition, and that is C3. And if you run it now, the answer, now enter the real part of C2. Okay, let's say 5, imaginary part of C2, let's say minus 2. So the answer is, so the first complex number is 3 plus 2i, second is 5 plus minus 2i. Okay, so if you add these, so 5 plus 3 will be 8 and minus 2 plus 2 will be 0, so 0i. It is so simple and the problem is over. Now this is basically the approach from the perspective of C programming. But if I have to make this program more elegant, means more close to the understanding, because this particular structure doesn't have any functionality so far. So why not to add the functionality to this complex number itself? And it is not a very big deal for you people. Look here. Now this I'll bring inside. Okay, let us shift it slightly, give some space. Okay, now also I will bring this inside. Now here in this addition function I will make certain changes. Okay, but before that let us focus on to how can we initialize this. This way of initialization is good because we can access the data members of a structure. That is not a problem, but this is not a very good initialization, because if you go to market and ask for, let's say, a pencil, then it should be having some standard dimension, and if not, then you should be telling, okay, this much dimension, this particular brand, and so on. So that control you should have. Okay, so this particular structure should have that control. So what you can do is you can make one function get data, and inside this function you can write everything which you have written here. So let us do what? Let us copy this part and bring it here. Now if you look, enter the real part, that's it, and that is what? Real. Why? Because I am in the complex number itself. I am talking of a complex number. I am talking of the real and imaginary part of that complex number only. So that's why only real. And likewise imaginary. Enter the imaginary part. That's it. Done. Now get data is also over. Then display is also. Now add we have to slightly change. What we are doing here is we are, let's say I'm having, let us remove everything. We will write everything here. So if I write this C1, then what should I say? COMP and then, sorry, get data. Okay, so I will say C1 dot get data. Now you can see that C1 is not only having real and imaginary part, but it is also having these functionalities. That is display, get data, add. So I will simply say get data, as it is not accepting any argument so far. So what I'll do, that's it. Once I run this, what will happen? This will ask for these datas. Okay, so so I can add one statement, cout, enter the complex number. Okay, now if I hide this particular statement for the time being and show you what will happen if I run it, so it will say enter the complex number. Okay, so now the control is with the user. Okay, so once I declare one complex number, that means structure, instance of this structure, then I can give the data to it. Okay, so far so good. I can also use this display. How? Simply by saying c1 dot display. That's it. So if I run it, what is the problem? Is there a problem? Let us check. Oh, display accepts one argument, and that is nothing but the complex number. So that is how we have defined it. But in this particular case, there is no need of it. What we can say, simply, as we are talking of a particular structure, so simply say real and imaginary. That's it. So if I run it now, so real part, let's say 3, imaginary part, let's say 7. So it will be displaying us as 3 plus 7i. No problem. Now from the program, I want to write inside this particular structure a function which will be capable of adding. So here I will keep everything as such. Now this is functionality of C1. So C1 is not only having this imaginary and real part, but apart from this, this is also having functions add and display and get data. Though they will not be taking any space in the memory, but still they will be having with the C1. These are the functionality this C1 can do. Okay, so now if I want to write add, so what I'll do, this is the C1. What the C1 will do, C1 will take another complex number and it will add the real and imaginary part of it and return the return that particular addition. So here complex add, okay, then this is not at all required. Again, this is not at all required, and that's it. What we have done, we have taken C1's real part, and inside C1's real part, we are adding that particular complex number which we are supplying to it. So basically, we are taking this. So this C1 is accepting this one, adding and then returning it to some another complex number. Likewise, this imaginary part, it is taking, adding and then returning it to some other complex number. That is what this particular program is doing right now. So if you take another complex number, let's say, let us make another complex number C2, and here I'll say C2, and simply if I run this, so it will run, no problem. Now what I have to do, comp, and let's say C3 is that particular variable. Now I'll say C3 assigned the value of, now look here first, what this particular C1 is doing. C1 is having this function known as add and it is returning as complex. So this add is taking another complex number. So what I'll say here is C1 dot add. That is what the functionality of C1 is. It can add. It can add what? It can add another complex number. What is that? It can add C2. And the result will be a complex number, so it can be transferred to another complex number C3. And once this has been done, you can simply say C3 dot display. So if you run it, now enter the real part 5, imaginary part 3. This is the first one. Now enter the second complex number. It is, let's say, 3 and 6. That's it. So the first is 5 plus 3i, second is 3 plus 6i. If you add 5 plus 3, 8, and 6 plus 3, 9. So it is so simple, friends. So in this particular lecture, what you have learned is how to write a structure. We have written a structure for complex number, not only from the point of view of C. People can argue that in C we have to write inside main this. Where is the main? Where is the main? Where is this is the structure? So where is the here is the main? We have to write struct. Okay, you have to write struct if it is exactly C. But the thing is, in C++, we are not only doing it using standalone, using that ordinary structure, but we are also doing it with the help of functionalities. So we are making this particular structure stand alone itself, having all the functionalities in it. So this particular structure is very close to the classes, and we'll learn it in the coming lectures that how it is very close. So in this lecture, till this point only. In the next lecture, what we'll do is we'll take another problem, we'll write structure for it. First we'll do it manually, that means without structures, and then we'll write structure for it. So in this lecture, till this point only. Thank you very much.